Alright guys, Math 1720, we are in Chapter 7, rounding out Chapter 7 here. We're doing algebraically defined vectors and dot products. We just wrapped up geometrically defined vectors, now we're doing algebraically defined vectors. Alright, so we really need to understand our interpret vectors, operations on vectors, dot products, and the angle between vectors, okay? I think you'll find this section rather easy. Just doing the algebra part with vectors. We will hit vectors again in one of your calculus courses as well. Alright, so let's get going. So, how do we interpret vectors using algebra? So what we call the vector, okay, that has an initial point at the origin. Remember the origin is 0, 0. We call that a position vector. Alright, so we write a position vector, u, that's we're going to use u and v for the most part, for most of our vectors, with its endpoints at the point. Alright, so we start at the origin, 0, 0, and then the endpoints are a, b. That's a coordinate system. Alright, so it's just a Cartesian coordinate, essentially. So if we were to sketch this out, alright, we would have theta, that's the angle between a and b, and the vector itself, we would describe it as vector AB because it starts at the origin. Alright, so vector AB can be drawn as such. Alright, where u is the magnitude of the vector, theta is the angle of the vector from the x-axis going counterclockwise. Alright, what we call A and B are the horizontal and vertical components of u, where A is the horizontal component, or your x value in the Cartesian coordinate system. B is your vertical component, the y value in Cartesian coordinate system. Alright, so the angle is positive, x-axis, and it's in the direction of counterclockwise, just like we started out in this unit, measuring angles. Alright, so how do we find the magnitude of a vector? It's literally just the Pythagorean theorem, because when we draw that vector, alright, it's at a right angle. So the magnitude, which is technically the length of our vector, alright, and we write it as vector u equals AB. So how we write that? The magnitude of u, so the absolute value, right, is the square root of a squared plus b squared. And the direction of said vector u is tangent of theta equals b over a, opposite over adjacent, or vertical over horizontal. So in order to find theta, you have to do tangent inverse of b over a. So very, very simple for us. Remember, a cannot be 0 because we'll have division by 0. So first example here, we want to find the magnitude and the direction angle for u, given that u is 3, negative 2. So first thing we need to do is find the magnitude. So you're going to have 3 squared plus negative 2 squared, all square rooted. Okay? And when we do that, we should get the square root of 13. Now, when you sketch the vector, alright, we can just sketch it generally so the angle goes from the x-axis and terminates in the quadrant where the vector lies. So since the vector is at 3, 2, the vector terminates in quadrant 4. So that's why you see theta sketched out as rather large here. So theta is going to be opposite over adjacent, and we're going to go tangent inverse of that. So tangent, in this case, is b over a. B is your vertical, A is your horizontal, so it's going to be negative 2 divided by 3. That's what tangent of theta is, and then you have to do inverse tangent of theta. So inverse tangent of negative 2/3, and then we have to add 360 because we need to end up in the correct quadrant for that. So know that it's 326. Okay? If we did tangent of negative 2/3, we would get the wrong answer for this. So just to clarify, alright, tangent inverse of negative 2/3 is negative 33.7, which is not incorrect. It puts us in the fourth quadrant, but we want to have the magnitude with a positive angle. Okay, so that's why we're adding the 360. So the negative 33.7 is correct. It puts us in the fourth quadrant, but we need to end up with a positive magnitude, so that's why we add the 360, so we get the actual positive angle there. So the solution here is square root of 13 at an angle of 326.3. Alright, your calculator will do vectors for you. I'm sure you guys are excited for that one. So on your calculator, if you hit second in apps, Okay, that's the angle command. And if you go down to number 5 and number 6, number 5 is the R with the PR, okay, so for the magnitude of the vector. So you're going to type it just like you see on the screen. So you'll select number 5 and then you'll type 3, comma, -2, close parentheses. The comma is above the number 7. All right, and then it'll give you the theta. Make sure that you're in degrees. So if you go down, if you hit second apps, that'll bring up the angle command. You'll go down to the vector. All right, so the position theta of 3, 2 is -33.69. So you can go through that on your calculators. Remember, once again, the commands there are hitting second and apps on your calculator. That gets you into the angle command. And those, at least on my calculator, which is a TI-84 Plus, gives you under the angle command number 5 and number 6 gives you the availability to find the magnitude and the directional theta for that. It won't put it in the square root of 13. That's just a verification here. It'll give you 3.60 when you do that. Okay, so I've always been talking to you about this almost literally since day 1 in the class. Always seeing cosine as horizontal, sine as vertical. So we want to be able to find the components now. So the first example, I gave you the components and you were able to tell me the magnitude and direction. Now I'm going to give you a theta, I'm going to give you a direction, and I'm going to give you a magnitude, and I'm going to ask you to find the components of the vector. So in order to do that, to find the horizontal component, which is A, you're going to use u times cosine of theta, and to find the vertical component, B, you're going to use u times sine of theta. Making sure we're in degrees mode here, okay? So we can rewrite vector u, okay? U of AB is really going to be u cosine theta, comma, u sine theta. So we're literally just substituting in. All right, so let's do an example here. We have vector W. It has a magnitude of 25 and a directional angle of 41.7 degrees. Find the horizontal and vertical components. So we're going to find A, we're going to find B. We have the magnitude, we have the direction. So to find A, it's going to be 25 times cosine of 41, and we get 18.7. So that's the component A. Component B is going to be W sine theta. All right, so you're going to take 25 times sine of 41.7, and you're going to get 16.6. All right, very easy to find the components. All right, and then we write the final solution in vector form here. So it's going to be 18.7 comma 16.6. So our solution is going to look like that. Horizontal component, then vertical component. Okay, very simple. I think you guys can easily get the hang of this one. Also, your calculator does it for you if you plug in the magnitude, all right, and the direction. So once again, you're hitting second apps and going into the angle command. And now, when you go down to line 7 and line 8, that's where you're going to get the horizontal and the vertical component. So when you do PRX, that gives you the horizontal component, and PRY here gives you the vertical component. Very simple to place into your calculator, and it does all that for you. Okay, so this homework assignment should be relatively a breeze for you. All right, so let's go through some practice examples here, writing each vector in the form. Those should be brackets where the question marks are, in vector brackets here. So all right, so if we take a look at u, we can see the magnitude is 5 and the degrees are 60. So if we're writing it in its component form, it's going to be 5 cosine 60, comma 5 sine 60. All right, and then we should know the values for 60 using our 30, 60, 90 triangle. So we substitute those in. So we're going to take 5 times 1/2 and 5 times square root of 3 over 2. So our solution is vector u is 5/2, comma 5 square roots of 3 divided by 2. So you need to substitute in the values. So this is on your assignment if you have it in fractional form, all right? So you don't get to just punch right into the calculator and knock it out here, okay? Let's take a look at the next vector. It's in the direction to the left there, it's the pink one. All right, so the magnitude is 2, the direction is 180 degrees. So you're going to go 2 cosine of 180, comma 2 sine of 180. And we know that cosine of 180 degrees is -1, and we know sine of 180 degrees is 0. So we can evaluate both of those. So we're going to get -2, 0, right? So you're going to have 2 times -1, which gives you -2, 2 times 0, which gives you 0. Okay? And then let's look at the third vector here. We have W, all right? The magnitude is 6. The degree is 280, okay? So 6 cosine of 280, comma 6 sine of 280. All right, and that one, you don't have a nice triangle to substitute in for. There's not a good reference angle because it's really only 10 degrees right there. So this one you can use your calculator. So type in 6 cosine of 280, you should get 1.04, and 6 sine of 280 and get -5.9. All right, very, very easy on this part of vectors. All right, let's do some vector operations. We're going to add and scale vectors. So if we look here, here's how we add a vector. Notice all you have to remember is add horizontal components with horizontal components, add vertical components with vertical components. So when it's just like combining like terms. X's with X's and Y's with Y's. That's essentially what you're going to do. So you have A plus C and B plus D. Those are going to be how we can combine like terms. If we have a scalar, that scalar multiplies by each term. So we're going to take K times A and K times B. So that's how we scale a vector. All right, so we can add a vector, we can sum a vector essentially, right? And then we can scale a vector. Or we can do the opposite vector. The opposite vector means if we're given U as A1 and A2, then the opposite U would be -A1, -AU. And that's how we would do subtraction. Very important here. So when we subtract, same kind of concept though, it's going to be A minus C, B minus D. So horizontal with horizontal, vertical with vertical when we do these. All right, so let's take a look at this example here. We're going to let the vector U equal -2, 1, and the vector V be 4, 3. We're going to find U plus V first. All right. So that should be fairly simple for us. We're going to take -2 plus 4. All right, so that should give us a +2 there. And we're going to take 1 plus 3, which should give us a +4. So our answer should be 2, 4. All right, let's do another one here. Oh, sorry, I'm moving ahead of myself here. Here's how the resultant vector is though. All right, we see the vector U. We see the vector V. Remember, the resultant vector has to lie between those two vectors when we calculate it. All right, using the same U and the same V, we're going to take -2U. So we're going to multiply U by -2. All right, so it's going to be -2 times -2 and -2 times 1. All right, so our final answer as we work through that should be 4, -2. If you were to sketch this, all right, that's how we would sketch the vector, always starting at 0, 0, and then moving in your Cartesian coordinates in the X direction and in the Y direction. All right, that should be fairly simple. I'm not going to go into detail on that sort of thing. All right, let's do a subtraction now. We got 3U minus 2V. So 2 parts to this problem. We got a scalar on each one, and then we got to subtract. Do the scalar first, all right? So 3 times -2, 3 times 1, -2, or you can just do 2 if you want and do the subtraction piece later. So you can do 2 times 4, 2 times 3, get those values, and then we can subtract them. All right, so we should end up with -6, 3 minus 8, 6, all right? And then horizontal with horizontal, vertical with vertical, so you're going to go -6 minus 8, and you're going to go 3 minus 6 to get our values here. So we should get -14, -3. All right, as we're simplifying these down. All right, and if you were to sketch them out, you'd be able to draw the vectors, right, starting at the origin 0, 0, and plotting them in their Cartesian X and Y coordinates there. All right, the unit vector. All right, unit vector. This will apply to when you do matrices and things like that in linear algebra and things like that. Very interesting course for you, and then it'll apply again in calculus. All right, so a unit vector. It's a vector that has a magnitude of 1. All right, so we can notice either the horizontal component is 0 or the vertical component is 0. So when you take the magnitude, right, that's a squared plus b squared square rooted, you get 1. So we tend to define it as I is when the x direction unit vector, j is in the y direction unit vector. Okay, so any unit vector, we can express it in this form, AI plus BJ. All right, so we're going to use the unit vectors I and J to describe this. So if we look at the unit vector here, we can say U is 3I plus 4J. It's really just a simple way of us writing the vector differently. The unit vector is going to come in important in linear algebra and things like that when you have like the unit matrix and those sort of things. Okay, IJ forms of the vector. All right, it's just a matter of just rewriting them in unit form. Okay. Next, we get on to the dot product. The dot product is how we multiply vectors. All right, so it's called dot. Do not say multiply. You are dot producting. Product is the multiplication piece. All right, but we have U, which is AB, and V, which is CD. So when we write this, we're going to say we're going to say U dot V. So when we work this out, we're going to say it's called the dot product. We're going to do U dot V. The way we solve U dot V is you take the horizontal component times the horizontal component and add the vertical component times the vertical component. Okay, so it just ends up being A times C plus B times D when we do this. All right, so let's do the dot product of each one of these. So our first vector is 2, 3. Our second vector is 4, negative 3. So when we do the dot product, we should do 2 times 4 plus 3 times negative 1. Okay, so when we do this, we get a value of 5. So you got 8 plus negative 3, which is 5. Next one should be 6 times negative 2 plus 4 times 3. All right, so we're going to get negative 12 and 12. Sorry, I skipped ahead there. You're going to have negative 12 and 12, which ends up getting 0 when you find the dot product here. All right, so let's just go through some of the properties, of dot products. All right, so we got U dot V is the same thing as doing V dot U. So these are what you're going to kind of apply on your assignment. If we have U dot V plus W, okay, you're going to have to do U dot V plus U dot W. So make sure that you have all these properties written down so on your assignment you can just look at your dot product properties, be like, oh yeah, I'm just going to apply this one. All right, U dot V plus W ends up being U dot V plus U dot W. That's just the distributive property. You're going to dot U with V and U with W. Okay. Same if we go the other direction. All right. So if the dot's on the outside on the right hand side, same thing. It'll be U dot W plus V dot W. Then if we scale U dot V, the scale can come out, and we can rewrite this simply as U dot V times K or U dot KV. All right. The scale factor has to be able to present itself there. Anytime we do 0 dot U, we get 0. If we do U dot U, we get U squared, or the magnitude squared. Okay, so make sure that you got all these properties down for your homework assignment. You'll just have to, there'll be some basic ones that you have to kind of rewrite and solve as you go through here. All right, next. So the geometric interpretation of the dot product. So in fancy words, we're just being able to find the angle between the two vectors using a dot product method. Okay, so if we have two vectors, U and V, and they're anywhere, the angle is anywhere between 0 and 180 degrees, then we can find this. We can say that cosine of theta is equal to U dot V divided by the magnitude of U times the magnitude of V. Alright, so U dot V divided by the magnitude of U times the magnitude of V, that equals cosine theta. To get the angle, remember you're going to have to do second cosine or cosine inverse of that ratio. So we want to find the angle theta between the two vectors. We have vector U, which is 3, 4, and vector V, which is 2, 1. So first thing I would do, find the dot product here. Alright, so you should have 3 times 2 plus 4 times 1. So you got 6 plus 4, so you should end up with 10 for the dot product on top. And then we have to find the magnitude of U, the magnitude of V. Remember, the magnitude of U is going to be 3 squared plus 4 squared, all square rooted. The magnitude of V is going to be 2 squared plus 1 squared, all square rooted when we do that. Okay, so when we get all that, substitute those values in, and that's going to be your cosine of theta. Cosine of theta is 10 divided by 5 square roots of 5, which is really 2 over the square root of 5. But you have to do cosine inverse of that to get the angle. So you're going to take cosine inverse of 10 divided by 5 square roots of 5, and you should get 26.57. Make sure you're in degree mode when you do this, and I need you to make sure that you plug this into your calculator correctly. I would do 10 divided by parentheses 5 square root 5, close the parentheses, all right? That'll make it so it's safe that you know what you're doing, all right? But work this problem a couple times to make sure that you get the same value that I have here on the screen. If you can't get this value, just email me, let me know. Just check your order of operations and being able to put it into your calculator correctly. Okay, there's not a nice calculator function for this one like there was for the others. Okay, so we want to find the angle theta between the two vectors. We're just doing the same thing. All right, just one more practice example. Why don't you pause the video and try it on your own to see if you get it correct, but I'll still walk you through it. All right, it's u dot v divided by the magnitude of u times the magnitude of v. All right, so we're going to substitute everything in. The little box there should be the dot product. I have no idea why it's not showing up on this slide. All right, but we should be able to do that. So the dot product will be 2 times 6, which is 12, plus negative 6 times 2, which is 12. So the dot product on top sends that to 0 for us. All right, and then on the bottom, we have to find the two magnitudes. So we should have square root of 4 plus 36 times the square root of 36 plus 4. All right, so that ends up the square root of 40 times the square root of 40, so we get 40 in the denominator. So we end up with 0 over 40, all right, but in this case, 0. So the angle between those two is 0. That should make sense, though. That you should notice if we have 2, negative 6, and 2, and 6, 2, all right, they're going to be opposites of each other there in directions. So it would make sense that the angle is 0 between the two, okay? So if we do cosine inverse of 0 on that piece, that's the ratio, so we end up with 90 degrees. Okay, so 90 degrees is the theta between vectors u and vectors v. All right, so dot product here, just some properties. Okay, for angles between theta, when theta is between 0 and 180 degrees and it's positive, we're going to get acute angles. If it's 0, okay, we're going to get right angles, and if the dot product is negative, we're going to get obtuse angles. All right, just a simple little chart to pay attention to that really kind of helps guide. So hopefully your dot product's positive, you get the acute. If your dot product's 0, like we just did in the last example, you're going to get a right angle, and if it's negative, you're going to get the obtuse angle. All right, and lastly, all right, if u dot v equals 0 for two non-zero vectors u, and cosine of theta equals 0 and theta equals 90, thus u and v are perpendicular or orthogonal vectors. All right, that's the last example we worked through. We ended up getting orthogonal vectors. Okay, so that's how we do that. So if that comes up on your homework and you look for orthogonal vectors, that should kind of give you a clue of how to set them up. Okay. Now, this ends chapter 7. All right. If you have any questions, don't hesitate to email me, or you need some problems worked through, or those sort of things. Likewise in class, go ahead, feel free to ask questions. We'll do some of those on the board. Else, guys, have a great day, and we will be moving on to chapter 8.